I'm going to be talking about Lightning and introducing you to where you can look to start with Lightning development. All right, so I'll introduce myself real quick. My name is Max. Yeah, I'm actually still a student at UC Berkeley studying computer science and economics. I've been in this space now for almost 4 years, ever since I started a GPU-based cryptocurrency mining startup. And that was kind of how I got my initial passion in Bitcoin and now about blockchain. I've worked at ChangeTip for a year, which is a Bitcoin micropayments company. Some other work that I've done some research into Bitcoin privacy and proof of work game theory. For the last year, I designed, wrote, and taught a survey course on cryptocurrencies and blockchains, which to my knowledge is still the world's only undergraduate survey course. Over the summer, I've been working on developer resources and advocacy at the Lightning Network. So the tutorials and other resources on the developer site, that's me. And then I've also been working on blockchain executive education, just kind of on the side. But the thing that I also spend a lot of time on is running blockchain at Berkeley. So we're a pretty vibrant community here in Berkeley with over 1,600 Slack and Meetup members. We teach multiple courses in our education department, have blockchain technical proof of concept consulting, ICO due diligence, do have research. There's a lot going on, and there's infinite ways to connect with our community. All right, so today I'm going to be introducing Lightning at a high level, and feel free to ask me questions about Lightning because I know it's kind of hard to understand at first. Then we're going to talk about some use cases, and then I'll take some time to explore some of the resources that we have at our disposal. Okay, so intro to Lightning. What is the Lightning Network? It's an off-chain settlement network, and it basically solves all the usability problems of Bitcoin. Currently with Bitcoin, if you and I are making a transaction, the rest of the world knows about it. And we have to make this transaction that's going to be stored on everyone else's hard drive forever. And we have to wait for 1 hour before it's fully confirmed and finalized safely. So what Lightning does is it basically enables you to fix all those problems where instead of having transactions shared to everyone with the world, it's primarily with you and the parties that you transact with. Instead of waiting an hour for safety, you have your transactions settle instantly. And because of that, you're not competing for block space in the Bitcoin blockchain. So you can send transactions with extremely low fees. And this allows also for us to send, perhaps thousands of transactions per second between us for micropayments and other kinds of use cases. So the Lightning Network is an overlay network that has these mechanisms in place that allow you to transact. But if something goes wrong, then you will always rely back on the security of the underlying blockchain. So in summary, you can kind of think the Lightning Network basically as infrastructure for speeding up blockchains, starting first with Bitcoin and hopefully also generalizing to other types of blockchains. So to quickly look at how it works, well, not quickly, but most of the time. Essentially, you have a 2 of 2 multi-sig address where both of the people will put their funds into it. And then what they're doing when they're making transactions is they're actually updating the transaction that spends from this multi-sig address. So anytime, perhaps we have in this address, both of us have 0.1 BTC. If Alice wants to give Bob, another 0.01 BTC, she will just Alice and Bob will both sign another signature or sign another transaction where Alice will now get 0.09 back and Bob will now get 0.11 back. And this is done in such a way that if you try to broadcast an old state, if you will, an old transaction that isn't the most up-to-date, then the other party can basically steal your money and take all the funds. So this is what enables Lightning to be trustless, so to speak. Yeah, so a quick review of cryptographic hash function before we go into the next part. Basically, it's a function that maps any arbitrarily sized data input to a fixed size output. And given the output, it must be very hard to find the input that evaluates to the output. So let's look at how this kind of works in Lightning setting. So in this instance, we've talked about how you can exchange Lightning transactions between two parties. But now let's see, okay, if I have an open relationship with Bob, if I want to go to this coffee shop and buy a coffee, just one time, wouldn't it be really inefficient for me to, also have to open another channel, so to speak, with this coffee shop? And that's exactly what we're trying to solve here. Using, it turns out that in the Lightning Network, you can actually route transactions between any number of nodes as long as there is a path of there's a path from you to the destination, and you're able to exchange payments still trustlessly. So let's look at one of these examples. These are the age-old Lightning slides that people have been using forever. So basically, in this scenario, Alice wants to pay Dave without opening a new channel with Dave, because that would be kind of expensive. So what he does is Dave hashes a random number, R, and then gives the hash H to Alice. So now Alice writes a contract on the Bitcoin network that to Bob that effectively says, okay, Bob, if you know R, the pre-image of H, then I will pay you. And then Bob has this guarantee from Alice that if he has the pre-image, if he has R, then he can pull the funds from Alice. Then now Bob has no problem saying to Carol, okay, Carol, if you know R, then I will pay you. And similarly, Carol says the same thing. Okay, Dave, I'll pay you, but only if you know R. But Dave actually knows R. So essentially what's happened is we've cleared in the forward direction. We've settled in the forward direction. So now Dave gives R to Bob and Carol. So Bob and Carol are now able to, they have the power to pull their funds from the previous party if they wanted to. So after we've all cleared in this direction, it's like, okay, well, we don't want to actually publish this contract that we just created onto the blockchain. Perhaps we should be doing this a little bit more efficiently. And since we have this safeguard, let's agree in our particular channels to basically revoke that on-chain transaction, and let's use an off-chain one instead. So when I say on-chain transaction, I don't mean that the transaction has been put on-chain. I just mean that in order for it to be effective, it would need to be published on-chain, and that's not something that we want. So through this method, you're able to create lots of payments between anyone in the network without the need to create these new channels. And it's really cool. So as long as there's a path, payments can be routed. And you can even imagine okay, if there, let's say, oh, my channel runs out of money or something. Well, if you have money in another channel, if you can find a cycle in this graph, then you're able to effectively send money to yourself and then rebalance your channels. So what are the advantages of Lightning? It enables micropayments. In this Lightning network, it's literally possible to send one Satoshi, which is one 10,000th of a Bitcoin, of a dollar, instantly. And effectively, how you get this scalability is through amortization. So whenever you set up one of these multi-sig relationships with another party, which is called a payment channel, you still need to create like that one on-chain transaction. But if you make a lot of transactions on this on this one relationship, then you're able to basically average out, make the average transaction fee very small over time. So you can imagine you can open a channel once, and then so long as you that channel has enough buffer room for you to continue sending payments or receiving payments, then you're able to effectively have use the Lightning Network with only one on-chain transaction fee. Yeah, and you're able to create any number of channels that you want. These channels can stay open indefinitely now with relative check log time verify, CLTV. And this is a lot better for developing, because instead of having this Bitcoin model where you have to send transactions and then later on you check if it's been confirmed, if it has enough blocks, these transactions are settled instantly, and it has a standard API of just generating a payment invoice and then satisfying that invoice. Yeah, okay, so looks like some questions are coming in. Yeah, what are the pros and cons of Lightning versus Bitcoin Cash? Yeah, good question. So Lightning is more, Lightning is a layer 2 technology versus Bitcoin Cash, which is still at the layer 1. So with Lightning, the idea is we want to not send every transaction on chain. We think that we can be a lot more scalable by building this building this off-chain settlement network, versus Bitcoin Cash is their idea is, oh, we want to make sure that the size of blocks is large enough to make on-chain transactions cheap enough to use, but then that there's downsides there in terms of the block size bloat. If you have really large blocks, then becoming a full node in this network, it becomes more and more expensive. So that's kind of I think that this is kind of a heavily politicized question, but Lightning and on-chain scaling solutions are totally they complement one each other. Better on-chain scaling also means better Lightning, and vice versa. How does Lightning compare with Ethereum, Raiden, and Plasma? Yeah, that's another good question. So Lightning Network currently is designed for the Bitcoin network. It's designed to send payments. Raiden is basically the Ethereum analog of Lightning. Raiden is also designed to send purely payments, and it doesn't really do anything else. Versus with Ethereum Plasma, Plasma is designed for state channels, so to speak. So instead of payment channels, and by that they mean, okay, let's take a smart contract execution off chain. Let's allow you to write arbitrary code that can be settled off chain. Plasma, I think, is a very cool technology, but it's still going to be years until we see it in production. So Lightning right now is actually very close to production if you want to play with it today. Cool. Yeah, and I guess the last point in this slide is Lightning is not suitable for very large payments. Basically, you can think of Lightning as your checking account versus your normal Bitcoin wallets as your saving account. So Lightning allows you to a lot of people have this false idea that, oh, to use Lightning you have to lock up your funds in Lightning. Well, it's not really locking up your funds if your funds become more liquid and you're able to spend it a lot more easily. But at the same time, one drawback is that you have to have your Lightning node online, or you need to periodically check the blockchain to make sure that no one's cheating on you. So because you don't want to have all of your money stored in a hot wallet, that's why we for now recommend using Lightning for just your small day-to-day Bitcoin transactions. Perhaps also sending money between exchanges, things like that. Okay, so quickly to differentiate between these layer 1 and layer 2 protocols, as Alex kind of asked about. So in layer 1, you write directly to the blockchain, and it has the highest amount of security because literally every transaction that you're making on the network is being validated by everyone. So this works well for, basically think like your savings account, think like the very high value payments. If I want to send, $10 million, I'm not going to mind a $20 transaction fee. But the limitation of this is that globally, we're constrained to 3 to 7 transactions per second, which is not really conducive to everyone being able to participate in this open financial network. Layer 2, however, it doesn't directly use layer 1. It uses the security of layer 1. Building on layer 2 is effectively what allows you to have a lower cost and suitable, and this is suitable for real-time use cases. So once again, this is like day-to-day payments. You can also imagine like for IoT, micropayments and things like that, or if you want to like stream videos, articles, Lightning is a great solution for that. So now we have some time to talk about Lightning use cases. This should be pretty fun. Oh, one thing that I also didn't address is that there is some enhanced privacy by default. So, someone observing on the blockchain, they don't know how many transactions that you and your counterparty have made in your payment channel. They only know like the end settlement amount. And furthermore, you're able to use something called onion routing in Lightning, which effectively allows you to hide the origin and destination of your payments. So that's a pretty cool feature of Lightning that we won't really be talking about today. So there's several use cases of Lightning. You can imagine, instead of being paid once a month and having your checking account almost run out of money once a month because you're fully invested in cryptos, you can have payroll by the minute. And that would be really nice. You can have micropayment paywalls that actually make sense. So, for example, you can replace it with a freemium model where, okay, I'll read like maybe the first 1 to 3 paragraphs of this article, and if it turns out that I want to keep reading, then I'll click a button and it'll send maybe like 1/10 of a cent to this to the publisher, and then if everyone does this, then that is enough revenue to essentially save these media companies. You can apportion everything into small micro bits of content that you want to consume. If you want to pay per video, or maybe you even want to pay for like second of the video that you watch, that totally works too. Also for music, streaming music, or if you want to if you for some reason want to bring like the economic disparities of our real world into our virtual games as well, you can replace virtual game currency with real like Bitcoin, and that would be a pretty fun dynamic. Some other IoT use cases include like you always hear those buzzwords, like machine-to-machine payments, like this autonomous economy. IBM Adept, for example, talks about a scenario where like a washer and TV are both trying to the TV is trying to stay on for the owner, and the washer is trying to wash its cycle, but it's a peak high point in electricity and the owner's home. So what the TV does is it basically tells the washer like, I need to have access to this energy right now because the owner's home. I'll make a small payment to you so that you can delay your wash cycle until the electricity is a little bit cheaper, and this is how you can make the system a little bit more energy efficient overall. So kind of sounds kind of gimmicky, but that's like the things that would be possible using Lightning as like a payment layer. Also, you can imagine like paying for metered energy. Like you can charge drones this way, you can charge electric cars this way, maybe charge your phone this way. These are all possible. let's see. Someone said, yeah, Square has announced the support for Bitcoin. Are they using the layer 1 only? They are using layer 1 only to my knowledge, yeah. If you actually look at Elizabeth Stark, she responded to that tweet, or she tweeted about it, and she said, oh, it would be even better if they use Lightning, because Lightning is almost, in some senses, like a strictly superior version of Bitcoin, except for the hot wallet part. Yeah. Some other use cases of micropayments and cryptocurrencies in general. I think one of the coolest ones is making finally our internet DDoS resistant. So imagine that if you could embed a micropayment in each internet packet, where at every hop in the internet, you're dispersing a small micropayment. Now this makes it very expensive for someone to just flood the internet and attack some central server. And I think this is cool. I think someone definitely needs to build this, and maybe one of you in the audience is also just as excited as I am about potentially making a DDoS resistant internet. Just because currently the way things are done is the internet is very sending packets and receiving packets is completely free. And basically all the nodes just mindlessly continue to forward packets to one another, even though it contributes to an attack. Other things that you can do. Oh yeah, internet packets are small. How big would the Lightning transaction inside of that packet be? I don't have good numbers. I would check with Lalu in our developer Slack, but this is something that that we've been talking about more internally, but just hasn't been really formally presented much. Yeah. And then, yeah, you can also do things like pay per API call, where instead of signing up for an account and loading up with a bunch of money to be able to pay your Google Cloud or whatever, you can just pay for every single call that you make, and this allows you to maintain anonymity and privacy as well. You can also say, oh, we can open access to our internet, and you can pay by the megabyte. There are also some financial use cases as well. So in general, Lightning allows you to have low fee irreversible payments. And from a qualitative standpoint, if that's better than our traditional credit cards and what have you, then perhaps Lightning would be the way to facilitate this. Also, when you have Lightning enabled, one of the first parties that are going to integrate this is basically the cryptocurrency exchanges, where there's a lot of money flowing in and out of them, and they're paying very hefty fees to get this onto the network. So you can even do high frequency trading, because the payments can be sent effectively as fast as you can send packets around the internet, and that'll be a very interesting to see how arbitrage between exchanges crops up after Lightning is more fully in production. Lightning is also great for decentralized exchanges. So it can not only just send payments across the Bitcoin network, but it can also do off-chain, cross-chain atomic swaps. So I could send a Lightning transaction that starts in the Bitcoin network, goes through a node that converts it from Bitcoin to Litecoin, and then to my end destination in Litecoin. That's all possible with Lightning, and it's also totally possible to implement a completely decentralized exchange between a number of cryptocurrencies fully on Lightning with an order book and what have you. Also, Lightning reduces the risk of theft at these centralized exchanges. So effectively, if you open a channel with an exchange, you're able to, what happens is the 2-of-2 multisig, the money can only go to you or the exchange. So when someone hacks the exchange isn't holding all the money. Like the money can only go to you or the exchange, and that kind of that is a big mitigating factor for this risk of theft at these exchanges. There are some edge cases there, but that is a possibility. And this is kind of an experiment on, okay, perhaps it is a lot harder to hack the private keys of a large number of users than it is to hack the single private key of one exchange, just from a key management standpoint. Yeah, there's also a question here. How many coins will be able to use the Lightning network? Bitcoin, Litecoin, Vertcoin. We're not. I mean, currently we support Bitcoin and Litecoin, but we definitely want to expand in the future. I don't think we support Vertcoin currently. Yeah. What date will Lightning be expected to go into production? Yeah. So no concrete numbers, but we're definitely trying to build it out as fast as we can. It's been on the testnet for quite a while now. You can connect to the Bitcoin testnet and send Lightning transactions on it. Will LN be resistant to quantum computing? Let's see. That's a good question. That kind of so Bitcoin itself currently is not resistant to quantum computing because we use elliptic curves. And with quantum computing, you would presumably be able to solve the discrete log problem. And Lightning relies on the security of Bitcoin itself. So if Bitcoin is not if it's not quantum secure, then Lightning is probably also not quantum secure. It's a little bit weird though, because you have transactions that are purely off-chain, and if the data is not exchanged with the attacker, they would not be able to get your private key, so to speak. And Bitcoin has this nice property that addresses are actually the hashes of your public key, and in order to steal your money, someone basically has to know your public key, which they won't if you've been following the standard best practice of Bitcoin of using a new address every time. So kind of an long involved answer, but in general, I think that if quantum computing actually comes about, then the Bitcoin developers are definitely smart enough to resolve that, and that will be implemented in Lightning as well. Yeah, so precisely, if Bitcoin gets an update to be quantum resistant, then that will also impact the Lightning network in terms of how we do transactions, how we sign them. Maybe we're using a different type of cryptography. Yeah. Like I said earlier, we're not sure about when Lightning is going to come out yet. I'm also very curious about this question. We've said the next, hopefully within the next month, but we've been saying that for the last few months now. So yeah, as soon as we're ready, because we take security to be much more important than shipping time. We want to make sure that it's when we launch our beta, that it's not just suddenly possible to steal the money and lose the faith of everyone. So yeah. So other blockchain use cases, you can pay for blockchain services, and you can incentivize these services. So for example, running full nodes on a network is a service that is absolutely needed, but there's very little incentive to do so because no one really pays you for that. But with Lightning, you could attach a small Lightning transaction with every request. And that's how you can effectively pay for these full nodes. And other things a lot of what these blockchain products are selling, we want to create a decentralized storage platform or decentralized computation or oracles or an arbitration network. A lot of those things don't actually need a token, and when it comes down to it, Bitcoin or Ethereum or Ether suffice as like the token. So what if you could just use Lightning or the off-chain version of Ethereum to directly pay for these services and not deal with this like token that has to that expends this on-chain blockchain cost. So Lightning is kind of like a counter example in this sense. Counter example for a lot of these blockchain projects that claim that they actually need tokens, because most of them really don't. And then some other use cases. Cryptographers tend to talk about betting and gambling. So you can have like trustless, you can have like fair gambling, but when is fair gambling really fun? And then you can also have some experimental protocols, that leverage game theory or whatever to, for example, to surface high quality content. So one idea that I've had for a while, and I'm hoping maybe one of you guys is also interested in building, is this idea called a tipster, where it's kind of like a Reddit where you pay to upvote. But the caveat is that when you pay to upvote, your payment is distributed to all the people that upvoted before you. And so what that means is if you are kind of in like one of the first people that upvoted this content and it becomes very popular and receives a lot of upvotes overall, you're able to basically get money off of that. And so this incentivizes, this creates profit opportunities for people who know how to identify, high quality content and content that they think other people will like. And so you can imagine, oh, we've basically created this like, zero-sum game where like hipsters or tipsters, or we should say, are able to earn money by like curating content. Yeah, let's see. B West also had a question. No Vertcoin. Yeah, no Vertcoin. We're currently focusing on just like the biggest cryptocurrencies. Like even Litecoin is somewhat of it's not the most well used, but Litecoin is so similar to Bitcoin that okay, it's very easy to just like directly implement Litecoin, versus Vertcoin has its own different like proof of work algorithm and a bunch of other like network parameters that are different that we would need to consider when integrating Lightning onto it. Yeah, and someone asked for my email. You guys can reach me here, typing it out. So to kind of conclude on these, these Lightning use cases, and talking not just about Lightning itself, but also just using cryptocurrencies in general. So the nice thing about cryptocurrencies is that they are, one second. Yeah. So the nice thing about cryptocurrencies is that they're neutral. These blockchain systems are designed to where there's no primary beneficiary for it. So if we wanted to implement a I don't know, a IoT economy on Venmo, well Venmo is going to be the one who benefits from that, versus like Bitcoin, there's you're literally rewarding the people who secure the network and make it run. So it's very well suited for horizontal integration, or where you need to have a lot of parties integrate onto this platform. Furthermore, cryptocurrency payments and Lightning payments don't require personal information. So that's really nice. You're able to now you're able to send money to pseudonyms across the internet, and internet personalities that where otherwise they would have to reveal like their personal information. And the nice thing also is that these cryptocurrencies are irreversible. So depending on your use case, this may or may not be desired, but as Elizabeth Stark says, reversible systems can be built on top of irreversible ones, but not vice versa. So the nice thing here is that because you have irreversibility at the base layer, this is what enables you to have essentially a very low cost, efficient base layer. And if you ever want to build the reversibility on top, you can always do so. So and that's another benefit versus like with like credit cards, chargebacks are a huge problem. And also Lightning is like the checking account of Bitcoin. It basically adds these nice properties of microtransactions and instant finality to existing benefits of cryptocurrencies, just like normal vanilla Bitcoin. All right, so here, 1 second. I just wanted to quickly show you the Lightning developer site. If you go to dev.lightning.community, this is kind of our like where we put all of our resources around Lightning. So starting off, if you want to learn more about the Lightning Network in general, we have a nice resources page here. And this includes a bunch of like links to articles and videos and papers and talks that like cover various assets and also are categorized by beginner, intermediate, advanced. And also we have reference to like the different developer tools that you have available at your disposal. For example, you can look. Oh, okay. I guess something's going wrong here, but we have our Lightning API reference. So this is pretty nice. Yeah, so we also have a nice community. If you want to join our Slack, it's always popping all the time. So there's an invite link here, etc. If you want to like really understand Lightning at a high level, I would personally recommend reading through the L&D overview and developer guide. I wrote this, and this kind of this kind of in text summarizes some of the a lot of the ideas that I was talking about today, like channel updates, what happens here, what happens when you want to make multi-hop payments, and then it also talks about some of the frequently asked questions like the network topology of the network, as well as like the basic mechanics and how the Lightning Network is exposed in a command line client. Yeah, as well as like the channel lifecycle, what happens, payment lifecycle, what happens when you like make an invoice and receive payments. Yeah, so definitely check out this website. If you have any questions, don't hesitate to email me. I think that's it. Yeah, so thank you everyone for watching. Yeah, take care.